Hi everyone, my name is Abhiraj Garakapati. Welcome to my YouTube channel Amazing Abhi. Before we talk about paths and devices, picture the machine as a large apartment building. The building can host very different tenants, and each tenant has its own way of living and using shared services. The operating systems are those tenants. Some need complex storage and console services, some specialize in virtualization, and others focus on Linux or very high transaction volumes. The important lesson is that the I/O configuration cannot be designed in isolation. You first need to know which operating system lives in each partition, because that choice influences the channel types and device access that the partition will need. This topic gives us that context so the later path decisions feel logical instead of arbitrary. Think of these 5 operating system families as 5 kinds of businesses renting space in the same large complex. ZOS is like a large department store, because it uses a broad range of services. ZVM is more like a building manager that can create smaller virtual spaces for guest systems. Linux on Z brings familiar Linux distributions onto the platform and commonly uses FCP storage and OSD networking. ZVSE represents an older batch-oriented style that still appears in some environments. ZTPF is specialized for very high transaction volumes. The names matter, but the bigger point is that each operating system has a different I/O personality. When we later decide which channel path types belong to a partition, the operating system inside that partition is one of the first facts we need. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing Abhi grow naturally. If you want to understand why operating system knowledge matters, ZOS is the clearest example. Imagine a large hospital campus. One road brings in medical supplies, another entrance handles staff, a dedicated line supports emergency communication, and specialized links connect different buildings. ZOS has a similarly broad set of I/O needs. It may use FICN for storage, OSD for networking, OSC for consoles, and coupling channels when participating in a sysbus. The key lesson is not to memorize every channel type on this slide. Instead, remember that one partition may need several different types of connectivity because each type performs a different job. When the configuration author knows the workload and the services it needs, the CHBID choices become much easier to reason about. A useful way to picture ZVM is as a hotel manager. The hotel owns the real building, elevators, doors, and utility connections. Guests do not rewire the building every time they check in. Instead, the manager gives each guest controlled access to the resources they need. In this comparison, the ZVM partition receives real I/O paths from the machine configuration. ZVM can then virtualize those resources for guest operating systems such as Linux. This explains why a Linux guest under ZVM is different from a Linux operating system running directly in its own partition. The guest may see a clean virtual resource, while the host is the one that actually owns the underlying channel path. The configuration still matters because the host cannot virtualize access to a resource it does not have. Before we move ahead, please take a second to share on this video. Sharing helps this video reach friends who may also enjoy anime, gaming, travel, cricket, chess, career basics, or personal stories. Your support helps Amazing Abhi grow naturally. Not every workload looks like ZOS or Linux. That is why these specialized operating systems deserve a place in the mental model. ZVSE represents an older batch-oriented style that is still present in some environments. ZTPF is designed for extremely high transaction volumes and has its own way of working across systems. Think of it like comparing a warehouse and an airport control center. Both are important facilities, but they organize traffic very differently. The I/O configuration needs to respect that difference. The configuration author should not assume that one set of channel types fits every partition. The operating system, the workload, and the services it expects must be understood first. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing Abhi grow naturally. This slide turns the operating system discussion into a practical configuration question. Imagine buying the correct electrical plug for a device. The wall may have power, but the device still cannot use it if the connector type is wrong. Channel path types work in a similar way. A Linux partition commonly expects FCP for storage and OSD for networking. A ZOS partition may need several additional channel personalities, such as OSC, and coupling ZTPF and ZVM have their own patterns. The exact design depends on the environment, but the principle is simple. First, identify the operating system, then identify the service the partition needs. Only then choose the channel type. This is why I/O configuration is a team activity involving system, storage, network, and operating system knowledge. The most useful way to leave this topic is with one simple rule. Before configuring a channel path, ask which operating system will use it and what service that path is meant to provide. The machine can host very different operating systems at the same time, but those operating systems do not all consume I/O in the same way. ZOS has the broadest set of needs in the source material. Linux commonly focuses on FCP storage and OSD networking. ZVM can act as a virtualization layer for guests. ZVSC and ZTPF represent different workload styles again. In the next topic, we move one level down from the operating system to the logical partition, the virtual computer that gives each operating system its own isolated place to run. If you enjoyed this video, please hit the like button and subscribe to Amazing Appy. Subscribing makes sure you do not miss the next video, and it gives me motivation to keep improving the quality of every upload. Thank you for being here, and I will see you in the next one.